Hi everyone, this is Candice Young. Thank you for joining my presentation today. In this presentation, I will be discussing my final project on developing a machine learning model to predict the electrical energy output of a combined cycle power plant. We're going to be using the dataset provided by the project. It includes approximately 9,500 hourly average ambient environmental readings from sensors at the power plant. We have four variables: temperature, ambient pressure, relative humidity, and exhaust vacuum. The goal is to use these environmental variables to predict the plant's hourly energy output. This is a mere regression problem because we'll be using historical data to develop the model. I'm going to be using MSE and R-squared to evaluate the performance of the models. We expect MSE, or mean squared error, to be lower the better, as lower MSE indicates a better fit. And we want to see a higher R-squared value closer to 1, which indicates a stronger correlation between the predicted and the actual values. I use Excel to run the data analysis against the provided data set, and I found that the temperature and the exhaust vacuum have a stronger negative correlation with the output. As you can see from the visualizations on this slide, that as temperature and exhaust vacuum increase, the output decreases. So I will compare the performance of the models that use all features against models that only use temperature and exhaust vacuum. I'll be comparing three different machine learning algorithms. Linear regression is a good baseline model, but it can be prone to overfitting the data. And lasso regression is similar, but it can help mitigate overfitting and potentially handle noisy data. And ridge regression is just another approach to reduce overfitting. And to validate the models, I'll be using a fixed validation approach, with 90% will be training data and 10% being the testing data. The next three slides are the results of each algorithm I used. I used a plugin called SLStat for Excel, and I'll provide a link to download the Excel in the video description. And this is a summary of comparison of all three algorithms. When we use all features, all models had a pretty high R-squared values, as they're all above the 0.9, and that tells me that they're a good fit to the training data. And if I just use ambient temperature and exhaust vacuum, we see a slight decrease in R-squared. That tells me that the other features might still contribute a little to the model's performance. However, the decrease in R-squared is also accompanied by a more significant decrease in MSE for all models when using only temperature and exhaust vacuum. This tells me that if we use less features, the model becomes simpler and potentially learns the underlying relationship better. And this can lead to improved performance on unseen data despite a slight sacrifice in training data fit. So if we look at both linear regression and lasso regression, they both perform very similarly with all the features and with just temperature and exhaust vacuum. But lasso regression might perform better with noisy data. If we look at the ridge regression, it has a slightly lower R-squared compared to lasso and linear regression, especially with all the features. While the MSE with all features is closer to lasso and linear regression, the drop in R-squared when using only temperature and exhaust vacuum is larger. That means it might be overfitting slightly more to the training data. So in summary, based on the results, both linear and lasso regression have a pretty strong performance. But I will consider lasso regression will be a better choice here because it might perform slightly better with noisy data, and it could potentially set coefficients of irrelevant features to 0. And that gives us a simpler model. And lastly, because I chose lasso regression, I took the intercept and coefficients from lasso regression, plug it into my testing data, and then compare the predicted output against the actual output. I now have R-squared equals to 0.918 and MSE equals to 23.35. Based on the results, I think lasso regression model using only temperature and exhaust vacuum features seem to have a good balance between model complexity and performance. The higher R-squared value indicates a stronger relationship between the model's prediction and the actual output values. The MSE is moderate with a value of 23.35. It tells me that there is a reasonable average squared error between the predicted and actual values. So this will conclude my project presentation. The Excel will be attached to the description of the video. And thank you very much for watching.